So today we're going to talk about wind turbines. So what is a wind turbine? Well, a wind turbine is basically a device that converts this rotational energy that it gets from the wind, which is a renewable source, and converts that into electrical energy that you can use to charge your light bulb or fan. And wind is a renewable energy, renewable source. So that's why windmills are considered renewable sources or renewable energies. Fun fact time! Did you know that an average windmill can produce 402,000 kilowatt hours per month? In other words, you could think of it as it can power a house, an average house, for a month in just 94 minutes of rotation. How does a wind turbine work? Well, first we have these three blades that you might have seen, and they basically help the wind move the turbine to generate electricity. Then, inside the middle, we have a generator, and when we rotate the generator, we're going to get electricity. And it's like an upside down motor, and actually you can just get your motor and rotate it, and then if you plug that into a light, the light will switch on. Since when you rotate the motor without plugging it in, then it's going to generate electricity. And it's very much like a generator is very much like an upside down motor, since in a motor, what do? You plug it, give it electricity, and it rotates. In a windmill, you do the exact opposite. You rotate it, and you get electricity instead of you giving electricity and getting rotation. So it's the exact opposite. So here I have an image of a generator, and so we have this is a rechargeable battery, and so here we have a copper rod. This is the armature. And we're going to rotate that. That's the thing we rotate. And here we have two magnets. And so when we rotate it, we're going to get something called eddy current. And eddy current is very much like it rotates. It's like a rotational current that starts inside the wire. And Eddie is not named after a person named Eddie. It's actually named after the whirlpool eddy or water eddy you might have seen when you drain the water from your swimming pool. And the reason is because it's very much like a eddy inside electrical current. Instead of in water, it's an electrical current. Okay, so how does eddy current form? Well, first we have a magnet. The simple idea is when you have a steel rod, then we have atoms inside it, and these atoms are all magnetic. And actually, all atoms in the world are magnetic. The reason why wood and plastic aren't magnetic and then don't attract to magnets is because they don't change their magnetic field. So if you could say this is steel, and so all these arrows are pointing towards the north pole of that atom. So this atom's north pole is here, and this atom's north pole is here. And so the atom's north poles are all pointing in different directions. And in wood, if you put a magnet next to it, these atoms don't change. But in steel, they all align. So since this is the north pole, south attracts north, so they all align. And in a permanent magnet, then these atoms are already aligned and they never change their magnetic field. They are always aligned. And that's why you have a south pole and a north pole. But in steel attracts both the north pole and the south pole and doesn't matter. And that's because it will always align. So if you attract the north pole and then attract the south pole, the electron atoms will just align to the new pole. And so in our generator, we're going to have this copper rod, and when you put a magnet next to it, the atoms inside are going to align to that new magnetic field. But then when you move it, they're going to have to realign since you moved it, and because of that, they're going to realign. And so you could think of it like this: if I get this magnet and put it here, then they all have to realign. And then if I could put it here, they would have to realign again, and then do it here, they would have to do it again. And so they're going to have to keep on realigning, and this motion of realigning and realigning is going to create eddy current. Fun fact time! Did you know that the largest windmill in the world is the new GE Halide X? It's about 853 feet. It's just a few feet shorter than the Eiffel Tower. And the new GE Halide X is in the ocean, and it's not in land. And because of this, since there's more wind in the ocean, and that's, you might have seen, if you see massive waves in the ocean, they're all caused by wind. And that's why you can see that in the ocean there's much more wind than in the land, so this windmill can get more electricity. So I'm going to be describing a few of these major wind farms. So the largest ocean wind farm is called the Hornsea one. And the Hornsea one is located next to Britain. It's in the ocean, of course, and it's located very close to the UK. As you can see, this is Leeds, and London is a bit below, and it's located here. And it has an energy capacity of 1.2 gigawatts. And it's the first wind farm to go above 1 gigawatt of electricity. The next wind farm that we have is called the East Anglia Array. And the East Anglia Array is located here. The other one was located here, next to Leeds, but this one is more closer to London. And the East Anglia Array has an energy capacity of about 714 megawatts. It's smaller than the old one, which was gigawatts, but still has a lot of electricity, 714 megawatts. The next wind farm we're going to describe is called the Ocean Wind Project, and that's the project where the GE Halide sits and is installed in, and it's installed inside the Ocean Wind Project is located next to New Jersey, and so this is New Jersey, so it's located here, and it has an energy capacity of about 1,100 megawatts of electricity. That's a lot of megawatts. Thank you for watching. I hope you enjoyed the video. Bye!